Transistor characteristics. There are two types of characteristics. So first one is called input characteristics. Second one is called output characteristics. Here, so here this input characteristics. So this is called VB and this is called IB. So base emitter voltage versus base current. Base current in microamps and base emitter voltage in volts. So by fixing the values of VCE1, VCE2, VCE3 like this, different values of VCE, so we will get the characteristics of input characteristics of these transistor. We will get like this. Okay, exponential is increasing like this. In this way, this exponential is increasing. So this is the input characteristics. Next, output characteristics is nothing but VCE versus IC. So VCE versus IC, collector emitter voltage versus collector current. So collector current in milliamps and VCE emitter voltage in volts. So by IB constant. So IB1, IB2, IB3. So by changing the values of IBC, so we will get different output characteristics. So for fixing for IB1 value of current, you will get like this characteristics. For IB2 like this, and IB2, IB3 like this. Okay. So these are the two different types of characteristics of transistor can be analyzed by using PSpice. So go to PSpice here. PSpice schematic, open PSpice schematic. So in this PSpice schematic, go to get new part. So enter here. Enter. So QN double two like this, and place QN double two QN. So this select this and then place here. Is clear? So QN double two. So this is called transistor symbol. Transistor symbol. So to get this new part, enter in get new part Q2N double two like this. You will get this element. Okay. And then next, so VDC, take VDC. So as per circuit diagram, we have to design here. Take VDC, connect like this. And also one more VDC is required. This is called VBE. And then here also one VCE, connected to emitter voltage is required. And then take one resistor here. So base resistor RB and collector resistance RC and emitter resistance RE. So to want this control R. So to rotate here. So control R like this. Okay. And take one ground also, connect to ground at the ground with it like this, place here. And then connect by using wire. So in this way. Okay. So these are the different types of components we can connect like this. So in this way, Q1 to a resistor and a resistor to this voltage source VCE and VCE2. In this way, connect like this fashion. And this is resistor to here, and this is resistor to here. Okay, and arrange properly. And connect ground also here. So this is called, what is this voltage? VBE, base to emitter voltage. That's why change the name of package reference. Package reference, that is called, change here VBE. VBE, save author, change display both name and value. VBE like this. Okay. It will be display here. VBE. Okay. The next, what is this resistor? RB. So change name like this. Package reference RB. RB. The next, this is called RC. Change the value of R2 to RC. And then save author. Change both name and display. You want display? Press like this. So like this, it will be display RC. And then next, this is called RB resistance. Na? Change RB resistance like this. Package reference to RB. Change R1 to RB. Save alter, then okay. RB. This is called RE. Sorry, this is RE. Change to RE. Emitter resistance RE. Save alter, then okay. And VB is over, and also this is called VCE, collected to emitter voltage. Na? That's why, so change VT to collected to emitter voltage VCE, then okay. And this way. So this is the circuit design. Design of transistor characteristic circuit. So input and output characteristics. So in this, first change the values of resistance also. Here take 20 kilo. 20 kilo. According to you, so if you want to change another values, you can as usual. You want to change another value, you want to get the characteristics of transistor for another value, you can. Okay. So change here, I'm changing the like this 100. Save alter, then okay. And here also I'm changing the values of 100, same. Save alter. Okay. So like this transistor circuit is designed. Okay, by using PSPACE. Then next, go to analysis. This is very important. Go to analysis and setup and enable DC sweep. Enable DC sweep. This is very important part. Okay, enable DC sweep and go to DC sweep. And here this is called voltage source. And name here, write here name. First name is called VBE, like this. Okay, VBE. And the next starting value of VBE, it changes like this. For starting 0, and then next 5 volts and increment by 0.2, like this. After this, nested sweep. Otherwise, if, for example, if the input side is arranged like this, source VBE 0, VBE name of the voltage source is called VBE, and the start value is called 0, and end value is called 5. So that means we will get the graph up to 5 volts. VBE voltage 5 volts. So first you want to know the characteristics of input side. So okay, at a particular voltage VCE is equal to 0. Okay, VCE is equal to 0 volts, and then what is the output input characteristics of input side? Okay, and then incremented by 0.2. That means graph will be incremented by 0.2, 0.4, 0.6, like this into increment up to 5. Okay, and then next okay, and then close. Okay, and then simulate. So before going to simulate, save this schematic. Schematic 3, like this, save. So after this, then next go to simulate. Press simulate here, then you will get characteristics, input characteristics. So where we will get the input characteristics means by using one current marker. So by using current marker only, you will get the characteristics, input characteristics. Otherwise, if there is no current marker, we will get it like this window, empty window. Okay, so either here we have to write trace where we want to plot. So you are go to trace and you are like this. This is the process is required. Otherwise, directly if you want to know the characteristics, input characteristics, so across the base current, this is called base current. By taking one current marker, I current, place here. So don't place on wire resistor and also on wire. So because of it's not taking, so by connecting the corner side of on element, and then only it will be take. Then only it will be possible to mark. Okay, so like this. So corner side, like this, just like this. So in this way, it is only possible to connect. Okay. current marker. But voltage marker can possible to connect anywhere in voltage marker. But current marker is possible to connect only corner side of the element. That may be resistor or voltage source or transistor. So your base current. Okay, that's why. So I'm connected here, this current marker here, and then simulate, and then you will get like these characteristics. So this is the input characteristics of transistor like this. So these is our input characteristics. One characteristics at one particular voltage. Okay, particular 0 voltage, VC 0 voltage. So this is the characteristics. Okay, first characteristics. And then next, so different values of VC and VC1, VC2, VC3. So we will get this type of characteristics. So by arranging some modifications in analysis, go to analysis and set up and go open DC sweep and then press here. So input side is called higher voltage. So VB is called high voltage. VB end value is called 5 and increment by 0.2. So this is the VB and linear. And then nested steep. Press this is called nested steep. And then in this enable voltage source, right here, this is called VCE. For different values of VCE, so we will get characteristics VBE versus IBE. Okay, that's why right here for VCE, so here VCE, and then enable linear, and then next starting value 0, it starts from 0. So VBE 5 volts, that's why, so the VCE must be less than 5 volts. That's why take 2 volts and increment by 0.2 right here, like this. Okay, and most important is called enable nested steep. Then only you will get multiple input characteristics at different values of VCE1, VCE2, VCE3. So multiple different input characteristics we will get then only by enabling the nested steep. Okay, so in a stable steep, then close. Understood analysis? So go to analysis, setup, and open. So first is called VBE, first source VBE, and then next starting value 0, end value 5, and increment by 0.2. And nested steep. Press nested steep and enable voltage source. Write VCE here, and then the VCE voltage is must be less than this VB voltage. Then only you will get proper output voltage waveform, input characteristics waveform. So linear, enable linear, and write start value 0, end value 2, increment by 0.2, and enable nested steep here. Plus enable this tick mark. Okay, then close, and then simulate. Then simulate, you will get like these characteristics. Okay, so different values of VCE voltages, VC1, VC2, VC3, VC4, like this. So you will get up to 0.5, 2 volts in the 0.2. For example, I'm changing the voltage analysis. Go to analysis, setup, and DC sweep, and nested steep. Nested steep I'm changing here, nested steep. So I'm changing like this, registered steep 0.1. Then what happened? We can see. So then simulate. So like this 0.1. That's why the more number of multiple waveforms will be generated. Okay, so that's why I'm reducing this analysis. Go to analysis, setup, DC sweep, and nested steep. So instead of 0.1, 0.5. Then we can easily understand. And then simulate again. So then these are the output characteristics. Okay. So to change the width of the, go to properties and the width change, like it can be visible properly. So like this, these are our input characteristics of transistor. Okay, transistor input characteristics, and then similarly, so the output characteristics we will get. So how means by changing the output side. So by changing the by placing the marker at collector side. Okay, so this delete this current marker and take a current marker and place on transistor IC like this. Understood? So here I'm placing the current marker. So if you want to place the current marker here, not possible. Okay, to place the current marker and wire, it's very difficult and it's not possible to place. So only corner of the transistor, corner of the element, we have to place the current marker. Okay, so this is the current marker. And to understand the output characteristics with the proper way, so we have to place the VCE higher than VBE. Okay, VCE higher than VBE. So go to analysis, setup, DC sweep. Here VBE voltage is 5. That's why I'm as it is I'm putting here VCE VBE is 5, but VCE is a higher one. So VCE end value is called 10 volts. Okay, then you will get proper output characteristics. So here increment by 0.5. Okay, next enable sweep, same settings, and here VBE is incremented by 0.2 na? So 0.5 means okay, then we will see so what type of output waveforms, multiple waveforms we will get. Okay, then go to simulate and press simulate and open like this. These are the our characteristics, output characteristics. So by changing this here, so setup, then you will get input voltage is called 5 volts now. For example, 2 volts. So enable like this and then simulate, and then you will get like this. This is the characteristics. So exponential is increasing up to 2 volts now. So I'm changing the voltage here instead of 2 volts. Setup and the DC sweep, 2 volts instead of 2 volts, 10 volts, 6 volts, or 8 volts or 10 volts. Must be less than the VCE 10 volts. That's it. Okay. And place like this and simulate. So like this, these are the characteristics. And also I'm changing the instead of 0.2, 0.2, 0.5. So less number of multiple waveforms we will generate, then you can understand clearly. So like this. Okay. Further, I'm reducing this analysis here also 0.5 no? 1 volts, for example. DC sweep, nested DC sweep. So 10 volts, 0.5 instead of 0.5. So 1 volts close and then simulate, and then you will get like this. So this type of characteristics, are we are expecting. Okay, that type of characteristics are we are getting from the from this. Understood. So this is about characteristics of transistor. So exponential is increasing. Okay, with the different values of IG1, IG2, IB1, IB2, IB3 base currents, different values of base current. So this is called base current, 0 amps, 20 milliamps, and this is called what is this current? And this, so IC versus VCE, IC versus VCE. This is called VCE voltages. So 1 volts, 2 volts, 3 volts like this. Okay, this is about characteristics of transistor.